Alright, let's go. Number 10. The Methuselah Star. In 2000, astronomers pointed the Hubble Space Telescope at an unremarkable star 190 light-years away in the constellation Libra and calculated its age. The answer they got back was impossible. According to every measurement technique available, star HD 140283, quietly orbiting in our own cosmic backyard, appeared to be older than the universe itself. To understand why this matters, you need to understand what stellar age measurements actually tell us. When astronomers analyze a star's chemical composition, its ratios of hydrogen, helium, iron, and oxygen, those ratios function like a cosmic birth certificate, encoding when and how the star formed. HD 140283 is what astronomers call a population 2 star, a second-generation relic from the universe's earliest era, formed from the sparse primordial material that existed shortly after the Big Bang. The problem is the numbers. Initial estimates place the star's age at approximately 16 billion years. The universe itself is only 13.8 billion years old, according to data from the European Space Agency's Planck satellite. A revised 2013 analysis by Howard Bond of the Space Telescope Science Institute, published in the Astrophysical Journal, used refined parallax measurements to lower the estimate to 14.46 billion years, with an error margin of 800 million years in either direction. Within that margin, the star could still predate everything. ESA's Gaia mission has since produced more precise distance measurements for HD 140283, slightly narrowing the conflict between the star's age and the universe's. Most astronomers believe the discrepancy will eventually resolve within the error bars as measurement techniques improve, but eventually resolve is doing a lot of work in that sentence. The Methuselah star has not yet yielded a clean answer. It sits 190 light-years away, ancient and indifferent, its age still brushing against the edge of what the universe's own timeline permits. What else in our cosmic neighborhood might be quietly breaking the rules while we're looking elsewhere? Number 9. The planet that shouldn't exist. On August 27, 2009, a team of astronomers led by Cole Hellier of Keele University in the United Kingdom announced the discovery of a planet that, by the established rules of orbital mechanics, had no business still being there. Published in the journal Nature, the discovery described a world orbiting so close to its star that every model of planetary physics said it should have been destroyed millions of years ago. WASP-18b lies approximately 325 light-years from Earth in the constellation Phoenix. It is a gas giant with roughly 10 times the mass of Jupiter, what astronomers call a hot Jupiter. But its size is not what makes it remarkable. What makes it remarkable is its orbit. WASP-18b completes one full revolution around its host star in approximately 22.6 hours. 1 year on this world lasts less than a single Earth day. At that orbital distance, roughly 3 million kilometers from its star, compared to the 150 million kilometers separating Earth from our Sun, tidal forces should be catastrophic. The gravitational interaction between the planet and its star should be steadily transferring orbital energy away from the planet, causing it to spiral inward. Calculations suggest this process should drag WASP-18b into its star in as little as 1 million years, a geological eye blink in cosmic terms. The planet should be gone. It is not. The leading explanation is that WASP-18's host star has an unusually low tidal dissipation factor, meaning it resists the energy transfer that should be sealing this planet's fate. NASA's James Webb Space Telescope produced a detailed thermal map of WASP-18b in 2023, confirming extraordinary atmospheric conditions, but the fundamental question of why it still exists remains unresolved. In 2023, Coulomb and collaborators published the JWST findings in Nature, revealing temperature contrasts across the planet's atmosphere of over 1,000 degrees Celsius. Either we are observing WASP-18b in the final, fleeting million years of its existence, an almost incomprehensible coincidence, or the tidal mechanics governing how close orbiting planets die are fundamentally different from what we calculated. Both possibilities are unsettling in their own way. Number 8. The structure that breaks the universe's rules. In June 2021, Alexia Lopez, a PhD student at the University of Central Lancashire in the United Kingdom, stood before the American Astronomical Society and presented a discovery that made some of the most experienced cosmologists in the room deeply uncomfortable. Analyzing data from over 40,000 quasars in the Sloan Digital Sky Survey, Lopez had found a structure so enormous that the universe, according to its own foundational laws, should not have been able to produce it. The structure is called the Giant Arc. It stretches approximately 3.3 billion light-years across space, situated at a redshift of approximately 0.8, meaning we observe it as it existed roughly 9.2 billion light-years away. It comprises galaxies, galaxy clusters, gas, and dust, arranged in a vast curved formation, detected using a mathematical technique called the continuous wavelet transform under the supervision of Roger Close, also of the University of Central Lancashire. Here is the problem. Modern cosmology rests on a foundational assumption called the cosmological principle, which states that on sufficiently large scales, the universe is uniform and homogeneous, smoothed out, with no dominant structures. Theoretical work, including analysis by Yadav and colleagues published in monthly notices of the Royal Astronomical Society in 2010, places the upper limit for permissible cosmic structures at approximately 1.2 billion light-years. The giant arc is nearly 3 times that size. Some cosmologists argue the structure may be a statistical artifact, or a projection effect, an illusion of connectivity created by the geometry of the survey. Lopez and Close maintain it is real. And troublingly, the giant arc is not alone. It joins a growing list of oversized structures, including the Hercules Corona Borealis Great Wall, that collectively exceed the cosmological principle's limits. One violation is an anomaly. Multiple violations are a pattern. If structures nearly 3 times larger than the universe is supposed to allow keep appearing in our surveys, at what point do we stop calling them anomalies and start asking whether the foundational rule they violate was never quite right to begin with? Number 7. The star with impossible chemistry. In 1961, Polish-Australian astronomer Antoni Przybylski pointed his telescope at a faint star in the constellation Centaurus from Siding Spring Observatory in Australia. The star, catalogued as HD 101065, appeared visually ordinary, a warm, relatively stable point of light approximately 355 light-years from Earth. What Przybylski found in its spectrum was not ordinary at all, and more than 60 years of subsequent analysis has not made it any less strange. When astronomers study a star's atmosphere using spectroscopy, splitting its light into component wavelengths to identify which elements are present, they typically find a predictable menu of hydrogen, helium, iron, and other stable elements consistent with the star's age and formation history. HD 101065 contains almost no iron or nickel, the elements that dominate most stellar atmospheres. Instead, its spectrum is crowded with absorption lines belonging to elements that have no reasonable explanation for being there. The star's atmosphere contains measurable quantities of short-lived radioactive elements, including actinium and protactinium, and some analyses suggest the possible presence of even heavier elements. This is where physics becomes difficult to reconcile. These elements have half-lives ranging from thousands of years down to much shorter timescales. They cannot have survived since the star's formation. Something must be producing them continuously. Right now, at the star's surface, in quantities large enough to register in spectra, taken from 355 light-years away. HD 101065 is classified as a rapidly oscillating chemically peculiar star, an ROAP star, meaning it pulsates and has an unusually strong magnetic field. The leading theories propose that this magnetic field drives exotic nuclear processes or causes gravitational separation and radiative levitation, concentrating specific elements at the surface. Multiple research teams using European Southern Observatory instruments have investigated these mechanisms across decades. None of them has produced a fully satisfying explanation. 60 years of spectroscopy later, the star still contains elements that have no business being there, and the universe has declined to explain itself. Number 6. Colder than the echo of creation. In 1995, radio astronomers Raghvendra Sahai of NASA's Jet Propulsion Laboratory and Lars-Åke Nyman of the European Southern Observatory trained the SEST, the Swedish ESO submillimeter telescope at La Silla Observatory in Chile, on a dying star's gas cloud in the constellation Centaurus. The temperature they measured in that cloud stopped them. Their findings, published in the astrophysical journal Letters, describes something that should have been physically impossible in the natural universe. The object is called the Boomerang Nebula, located approximately 5,000 light-years from Earth. It is a preplanetary nebula, the expanding shell of gas expelled by a dying star as it approaches the end of its life. The central star is ejecting this material outward at approximately 164 kilometers per second, one of the fastest outflows ever recorded for this class of object. The object had first been imaged by Keith Taylor and Mike Scarrett in 1980, but it was Sahai and Nyman's observations that revealed the true strangeness lurking within it. The temperature inside the Boomerang Nebula is approximately 1 Kelvin, 1 degree above absolute zero. That number requires context to be fully unsettling. The cosmic microwave background radiation the residual thermal energy left over from the Big Bang, permeating every cubic centimeter of space in the observable universe, maintains a minimum temperature of approximately 2.725 Kelvin. That is the floor. The universe itself, simply by existing, prevents anything from cooling below that threshold. The Boomerang Nebula is measurably colder than the Echo of creation. The mechanism is understood in principle. Gas expanding at extreme velocity loses heat through adiabatic cooling faster than the ambient CMB radiation can replenish it. ALMA, the Atacama Large Millimeter/Submillimeter Array, revealed additional complexity in the nebula's structure in 2013, showing a warmer inner shell surrounded by the ultra-cold outer region. The physics are not in dispute. What is striking is the scale of the violation. This is not a laboratory experiment. It is a natural object, 5,000 light-years away, that has somehow made itself colder than the universe allows. What does cold even mean at the edge of what physics permits? And how many other natural processes might be quietly breaching the universe's own boundaries in ways we haven't yet thought to measure? Number 5. The black hole that had no time to exist. In the constellation Canes Venatici, approximately 10.4 billion light-years from Earth, there is a quasar designated TON 618. It is one of the most luminous objects ever detected, roughly 400 trillion times brighter than our sun. At its center sits a black hole. When astronomers measured that black hole's mass using a technique called emission line reverberation mapping, the number they arrived at did not fit inside any model of black hole formation that currently exists. TON 618's central black hole has a mass of approximately 66 billion solar masses. For comparison, Sagittarius A star, the supermassive black hole at the center of our own Milky Way, confirmed by the Event Horizon Telescope collaboration in 2022, has a mass of approximately 4 million solar masses. TON 618 is roughly 16,500 times more massive. That alone would make it extraordinary. The timing makes it impossible. Because TON 618 sits at a redshift of z equals 2.219, we observe it not as it exists today, but as it existed roughly 10.4 billion years ago, when the universe was only approximately 3.4 billion years old. A 66 billion solar mass black hole must therefore have assembled its entire bulk within that window. Standard astrophysics imposes a hard constraint on this process. Known as the Eddington limit, it describes the maximum rate at which a black hole can consume surrounding matter before the outward pressure of radiation blows away its own food supply and stalls its growth. TON 618 is far too massive to have respected this constraint. Proposed resolutions include super Eddington accretion, consuming matter faster than the theoretical limit should allow, mergers between multiple massive black holes, or direct collapse formation, in which enormous primordial gas clouds bypass the stellar phase entirely and collapse straight into black holes. Each of these mechanisms has theoretical support, but none has been confirmed at the scale required to produce an object like TON 618. TON 618 doesn't just challenge our understanding of black holes, it challenges our understanding of time itself, because the universe simply hadn't been running long enough for something that massive to exist when it appeared. Number 4. The spacecraft that went to the wrong place. On March 3, 1972, NASA launched Pioneer 10 into the solar system on a trajectory toward Jupiter and beyond. Its twin Pioneer 11 followed on April 6, 1973. For decades, engineers at NASA's Jet Propulsion Laboratory tracked both spacecraft with extraordinary precision using the Deep Space Network, radar ranging accurate enough to detect discrepancies of a few hundred meters across billions of kilometers of empty space. In 1980, they noticed that both spacecraft were in the wrong place. Not by much, but by exactly the same wrong amount in exactly the same wrong direction. This was not a navigation error. Both spacecraft were decelerating at a rate of approximately 8.74 times 10 to the negative 10 meters per second, squared more than the known forces of gravity could explain. The anomalous acceleration was tiny, roughly 10 billion times weaker than Earth's surface gravity. But it was consistent. It was identical on both spacecraft, and it pointed directly toward the sun. It persisted from approximately 20 astronomical units out to beyond 70 astronomical units. For 2 decades, it resisted every explanation engineers and physicists could construct. The Pioneer anomaly, as it became known, was formally published by John D. Anderson and colleagues at JPL in Physical Review Letters in 1998, and refined in a comprehensive 2002 study in Physical Review D. During those years of open mystery, it attracted serious scientific proposals, including modifications to Newtonian gravity, a framework called Modified Newtonian Dynamics, or MOND, and speculative theories involving dark matter interactions and previously unknown physical forces. The resolution, when it finally came, was published by Slava Turyshev and colleagues at JPL in Physical Review Letters in 2012. The culprit was thermal radiation, heat emitted asymmetrically from the spacecraft's own electrical systems and radioisotope thermoelectric generators, creating a tiny but consistent photon pressure pushing back against the direction of travel. Detailed thermal modeling of the spacecraft's geometry confirmed the effect, matched the anomaly precisely. The Pioneer anomaly turned out to have a mundane answer. But it took 20 years, a revolution in thermal modeling, and serious proposals for new physics to find it. How many other small, consistent discrepancies in our current data are quietly accumulating, waiting for the right model to reveal what they've been pointing at all along? Number 3. The galaxy that the universe wasn't old enough to build. On March 3, 2016, Pascal Oesch of Yale University and his team published a paper in the Astrophysical Journal announcing the discovery of the most distant galaxy ever confirmed. Designated GNZ11 and located in the direction of the constellation Ursa Major, the galaxy sits at a redshift of Z equals 11.09, placing it approximately 13.4 billion light-years away in light travel time, observed as it existed only about 400 million years after the Big Bang. The universe at that moment was a toddler. What Oesch's team found inside it belonged to a much older cosmos. Galaxy formation takes time. In the standard cosmological model, galaxies build themselves gradually through the gravitational collapse of dark matter halos, the accretion of gas, the ignition of successive generations of stars, and the slow enrichment of their atmospheres with heavier elements forged in stellar cores. 400 million years is not long enough to produce a galaxy as massive, as chemically complex, and as vigorously star-forming as GNZ11 appeared to be. The model said it could not yet exist in the form it was observed. When NASA's James Webb Space Telescope turned its instruments toward GN-Z11 in 2022 and 2023, the mystery deepened rather than resolved. JWST confirmed the redshift and revealed an active galactic nucleus, a feeding supermassive black hole, at the galaxy's center, compounding the problem of how so much mass assembled so quickly. Even more strikingly, a 2023 study led by Andrew Bunker of the University of Oxford and published in Nature detected anomalous nitrogen abundances in the galaxy's atmosphere, suggesting exotic stellar populations or an unusually enriched chemical environment that no current formation model adequately explains. GNZ11 would be remarkable enough as a single exception. It is not a single exception. In the years since JWST began operation, astronomers including Ivo Labe and colleagues, in a 2023 Nature paper, have cataloged multiple galaxies from the universe's earliest epochs that are far too massive, too evolved, and too chemically complex to exist when they do. The community has taken to calling them, with quiet alarm, the impossible galaxies. GN-Z11 isn't an anomaly anymore. It's the founding member of a category, a growing catalog of objects that the universe, according to our best models, did not have time to build, and somehow built anyway. Number 2, the force that is rewriting the ending. In 1998, two independent teams of astronomers were racing to solve what they believed was a straightforward measurement problem. Both teams were using Type 1a supernovae as standard candles, stellar explosions with consistent peak luminosity that function as cosmic rulers for measuring vast distances. Their goal was to calculate how quickly the universe's expansion was decelerating under gravity's pull, and from that to predict the universe's eventual fate. Both teams expected deceleration. What they found instead rewrote physics. The universe's expansion is not slowing down. It is accelerating. The supernovae at the edges of the observable universe were dimmer than they should have been, not because something was absorbing their light, but because they were farther away than gravity alone could account for. Something was pushing the universe apart, overcoming gravity across cosmic scales, driving everything away from everything else at an ever-increasing rate. The Supernova Cosmology Project, led by Saul Perlmutter of Lawrence Berkeley National Laboratory, and the High Z Supernova Search Team, led by Brian Schmidt of the Australian National University and Adam Rees of the Space Telescope Science Institute, both arrived at this conclusion independently. All three were awarded the Nobel Prize in Physics in 2011. The unknown force responsible was named dark energy, a label that functions more as an admission of ignorance than an explanation. According to data from the European Space Agency's Planck satellite mission, published in 2018, dark energy constitutes approximately 68% of the total energy content of the universe. Ordinary matter, everything we have ever seen, touched, measured, or detected accounts for approximately 5%. Dark matter accounts for another 27%. The dominant ingredient in reality is something we cannot detect, cannot describe, and cannot correctly model. The leading theoretical candidate is vacuum energy, the quantum mechanical energy of empty space, described by Einstein's cosmological constant. When physicists calculate how strong this energy should be using quantum field theory, they get a value approximately 10 to the power of 120 times larger than the observed value. That is not a rounding error. It has been described across the physics literature as the worst prediction in the history of science. Preliminary results from the Dark Energy Spectroscopic Instrument, released in 2024, suggest dark energy may not even be constant. It may be evolving, potentially making the mystery still more profound. Dark energy is not one impossible thing found in space. It is the dominant component of reality itself, 68% of everything that exists, and our best theoretical framework for explaining it is wrong by a factor so incomprehensible that the number used to express the discrepancy requires 3 digits just to write down the exponent. Whatever dark energy is, it is deciding how everything ends, and we do not know what it is. Number 1. The scar on the oldest light. In 2004, a team led by Paz Villalba of the Instituto de Física de Cantabria in Spain was analyzing data from NASA's WMAP satellite, the Wilkinson Microwave Anisotropy Probe, which had been mapping the cosmic microwave background radiation with extraordinary precision. The CMB is the oldest light in the universe, the faint thermal afterglow of the Big Bang itself, imprinted on the sky when the cosmos was only 380,000 years old, now cooled to a temperature of approximately 2.725 Kelvin. Villalba's team found something embedded in it that should not have been there. A patch of sky, measurably colder than everything around it, stamped into the first light of creation. The object is called the CMB cold spot. It sits in the direction of the constellation Eridanus. It is approximately 70 microkelvin colder than the surrounding CMB. A small